All right, so let's start talking about lab manuals. The first thing that you need to realize once we move into organic chemistry from general chemistry, the lab manual part is going to be a much bigger part of the course, and it's going to be a lot more work than it was in Gen Chem. So just be prepared to put the time in, right? We're teaching you how an actual scientist would do this. All right, so pretty simple stuff up here. We've got the title, your name, and the date, right? You need to date stuff. When did you do this, right? So this is not when you're writing the lab, but when you're actually doing the lab. Next up, we have, again, the title of the lab. I like to rewrite it just because it's kind of small over here. So I just like to rewrite it. So in this case, I'm just doing an example with this melting point, boiling point, and density practice. After that, we have some kind of objective. This is kind of what's the point of the lab? Why are you doing this, right? We're doing this to practice finding the melting point, boiling point, and density of some compounds, right? Short, sweet, and to the point, maybe 1 to 3 sentences, not too much. Next up, we have our table of chemicals. You can draw a little outline for the table too, if you'd like, right? So you need to list all the compounds you're going to use, for example, ethyl acetate, and then you need to give some good information about it, right? Definitely the molecular weight or the molar mass of the compound, that's always something that's useful. Possibly the amount. In this case, you probably don't need to use the amount because we're not using an exact amount, but in the future, we'll be doing chemical reactions where it says, use half a gram of this, right? Then you'd calculate half a gram of that. The millimoles, right? So we have the grams in amounts and then the moles in amount, right? Use the molar mass to go it. Millimole is just like millimeter, right? It's 1/1000th of a mole. And then other important information, right? Here, we're doing melting point and boiling point. So we want to know the melting point and boiling point. What does the literature say that it should be? But other times you're going to want other data here, right? If you were taking an IR, you're going to want to know IR peaks. If we're finding the density, you're going to want to know the density, right? So I probably should have had density here since we're taking the density, right? So I'd lose points there for not having the literature value of the density there. What else would you need? So sometimes you'll need refractive index, right? We're going to take some refractive index later on, so you're going to need to include that data. So you want to read through the lab, think about what data you're trying to pull from the lab, and get the literature data so you can compare and contrast how close your stuff was. And then below that or to the side, you don't have to organize it this way exactly, but you want the CAS number. We'll talk about that in a second here. And then the safety stuff, right? So ethyl acetate is flammable and it's an irritant, right? So you don't want to get it on yourself. Here we've got acetamide. It's a carcinogen. Again, you don't want to get this on yourself. So how are we going to find this data? We're just going to go ahead and use Google, right? The power of the internet. So for example, you're just going to type in the name of your compound and then MSDS, right? So ethyl acetate MSDS. You can see I've already clicked on some of these links. And the best ones I found are from these Fisher Scientific, right? You see how it says Fisher SCI, that's Fisher Scientific. They're a chemical company, so they sell chemicals. And so naturally, they're going to have a lot of these things. So you can click on this MSDS. I don't like this one as much just because it's kind of, I don't know, doesn't look as cool. I like the SDS better. It's essentially the same thing, just formatted slightly different, right? This one kind of looks more cool and professional, right? And so you can get a lot of information here, right? The manufacturer details made in Hanover, Pennsylvania. That's pretty cool just because I used to live like 30 minutes from there. Not important for us though, right? But you see the name of the compound is ethyl acetate. In the section 2, you see some hazards, right? This is flammable. This is an irritant. So this is what you want to write in your lab manual. And this is what you want to know when you're dealing with this stuff, right? Don't light this on fire. It's going to light on fire. Don't get it on your skin. It's going to irritate your skin. You want to know this kind of stuff, right? And so it tells you all kinds of stuff, right? What happens if you should eat it, inhale it, all this kind of stuff. You've got this safety triangle. The red is how flammable it is. So you see it's a level 3. The blue is a health hazard, so that's 2. And then the yellow is kind of other stuff. And then right here, we see the CAS number, right? So you're going to want this CAS number. Every known compound has a CAS number. And so this CAS number follows itself wherever you find it, whether you're talking to Fisher or Sigma or some other chemical company. It's kind of like the barcode or the social security number of the compound. And so you want to have that handy just so you can Google some other stuff. And of course, you can read through this SDS stuff, right? There's all kinds of good information there. right? And then they also have some good data here as well. So let's see. Right, so they have some densities, some solubilities, right? Some melting and freezing point, right? There's your boiling point, right? 77 degrees Celsius, that kind of stuff. So you can pull all kinds of information from these SDSs, right? And so you want to just go ahead and note all of that stuff there. Again, if you want to put it on the side or something, that's totally fine. Next up, we have the structure or the reactions. For in this case, we're not doing any reactions, so we're just going to draw the structures of the compounds. We have ethyl acetate, and we're going to draw the skeletal structures. Always skeletal structures. We're not doing Lewis structures anymore. And then acetamide, right? So you know what this compound looks like. And once you get decent at this stuff, you can look at it and you can kind of predict its properties. Oh, it's going to have a high, low melting point, that kind of thing. Later on, we'll have reaction schemes over here. So maybe you'll like, I don't know, go from acetone to an alcohol using some sodium hydride, right? Later on, we'll have reactions. Next up, we have our procedures. So the way I like to do this is on one side, have the procedures, and then on the other side, have the results and data. And so these procedures are very important, right? You need to make it clear. I would section stuff off, right? So the first thing we're doing in this lab is make some stir bars. And then later on, we're going to take some density, right? And so then you want to write the notes, right? This is what you're actually going to do step by step. It needs to be complete and it needs to be clear, not just for you to know what you're doing in your lab, but if anybody is reading your lab manual, they should be able to do the entire lab just using your lab manual. And so definitely take some time and some care into this. And then on this other side, results and data, I like to do it this way because you can keep everything nice and organized. So for example, we're taking density, we're taking the density of ethyl acetate. You want to describe the compound. What does the compound look like? It's a clear liquid here. This is important because if somebody goes in the lab and they see a white solid, they know they're not doing something right, okay? And so you want to keep your stuff characterized, right? And then write other data that you're going to need, right? When we're determining the density, we're going to need to know the mass of our empty pycnometer, the mass of pycnometer with water, and then the mass of the pycnometer with ethyl acetate. So you want to write these numbers down. And so these are the numbers you'd be writing down as you're going through the lab. And by doing this on this kind of left-right side, as soon as you do the procedure, you can write it down right there. And so your data is very well organized with how you're going to do this lab. And your procedure will be much longer than mine, right? I just wrote little squiggle lines. You can write smaller if you'd like. A lot of people write smaller than I do. Or you can just use a bunch of pages. Don't be afraid to just use a bunch of pages. It's not that big of a deal. Next up, we've got the calculation section. So here you want to show your calculations, how you got them, and all of the work, right? So one thing we're going to do is find the density of the ethyl acetate. So we're going to put some water in this pycnometer. And so we're going to want to know what's the mass of the water. Well, the mass of the water is going to be the pycnometer plus the water minus the mass of the empty pycnometer, right? And then here you'd actually write in your data, right? Where this says numbers, you want actual data. And then you can use the density calculation to figure out the milliliters of H2O. And then later on, you can find the density of ethyl acetate. So you need to find all your calculations and you need to show how you got there. And then when you're kind of getting to the end of a thing, right? So let's say you find the density of ethyl acetate as, whatever, 0 point some number, you probably want to box it in. Just make it very obvious that this is the end result of the calculations and that this is going to be something that's important. Next up, we get to a very important part, and that's this discussion and conclusions, right? So write out, what did you do during this lab? How did it go? What went right? What went wrong? What's the data you got? Oh, I observed a density of 0.75 grams per milliliter. The literature says 0.85 grams per milliliter. So I had a percent error of this, right? All this kind of stuff. The most important part of the section is what you learned and what went wrong. What improvements did you make, right? We're scientists. We make hypotheses, we test them out, and when we see what went right or what went wrong. So I can tell you right here, when we're going to watch the boiling point video, one thing I did that I messed up is in some of the boiling point apparatuses, I added too much ethyl acetate to them. And so here I wrote myself a note that when we're taking these boiling points, make sure that the liquid in the capillary is below the bell height, right? And so that's important to know to get good data. I don't expect you guys to do these labs perfectly the first time, but I do expect you to learn from it, right? It's totally okay not to be perfect. It is not okay to not learn, right? That's the whole reason that we're here. And write down any kind of other mistakes that you make, or if you're watching the videos that I make. If you're watching the videos that I make, most of these labs, this is the first time I'm doing them, and so there are plenty of mistakes. And I expect you to point them out here, as well as in your results, right? You could say maybe you like messed up here, right? And then write how you messed up or something like that, right? It's kind of hard to mess up the making the stir bar, but there's other experiments for like a titration. We over titrated. You could write over titrated, right? You want to keep good notes so that if someone comes back and looks at this from years from now, they understand what happened. Obviously, this is an educational experience, but in real life, this is very, very important, right? If you're working for a company, they don't care what you can do. If you can't write it down, you're useless. So we're going to teach you these skills. And then finally, you need references. So you need to reference our lab manual. That'll be the most often thing that you reference. And so here's in ACS format. So here's how the format goes. It goes the title of the authors. So it goes by the last name, and then a comma, and then the first initial, and then the middle initial, and then a semicolon, and then the name of the next author, right? Last, comma, first, comma, middle, right? And then when you go to, right, and then after that, you can just put a comma, and then it'll be the name of the book or article or whatever you're citing, right? And so in this case, it's going to be a microscale organic laboratory technique, comma, the edition, right? Here's the 5th edition, comma, the publisher, right? Wiley. And then finally, comma, the year it was published, or the year it was, published, right? So 2010 for our book, right? So there's a quick guide. You want to go through these labs, make good lab manuals. It's really important. It's good. It's nice. It's organized. Mine's not a perfect example of this, right? Obviously, I didn't write out all the notes, but you can see I made some mistakes here. This definitely would not be an A+ lab report, but it gives you a good idea of overall what you need to do.